Good morning, good morning. Hello, hello. I'm still a bit sick, but much better than yesterday. Okay, right. Okay, let's look at today's seminar. So if you don't have the notes, by the way, you can just get the PDF version on our website. Yeah, the same place where you join the seminar lah. Okay, you can get the PDF version there. Okay. Now, today will be our Form 4 seminar. Okay, and we're gonna split it into 4 different parts. All right. Okay, hang on. I'm opening up the notes first. Share screen. Okay, there we go. All right. So, like I said, today's seminar, we will split it into 4 different parts. Okay. The first part, we are going to focus on the motion graph. Yeah. Motion graph questions. That's part number 1. Part number 2, we are actually going to do some momentum related questions. Okay. Yeah. And then part number 3 will be this impulsive force and suvat is a combination lah. Okay, combination of impulsive force and suvat. Okay, and then the final part for today, right? We will focus on some essay questions. Okay, now, some schools might not be having essay for their first exam. It's okay, yeah. You still have to learn this because SPM you still have to know, right? For some schools, you might get essay question, but you probably never done any essay question before. So we will have to learn about that essay question today lah. Okay, I'll teach you about it. All right, these are called essay questions, this one. Yeah, okay. So we will start off with part number 1 first lah, huh? Okay, so probably we will wait for 1 more minute. I will start at 10:05 just to see whether anyone else joining us lah. Okay, so we will start in 1 minute time, huh? Right, let's begin with the first part of today's seminar. Now, the front pages, the first 3 pages, these are short notes. You can always just refer to them before your exam, okay? So right now, we will start with page number 4. Okay, open up page number 4. We will start with the first motion graph question. So here we have a cyclist moving forward on a straight horizontal road. So it's just a straight road only, no turning. This is the velocity time graph of the bicycle, meaning at every second, how fast is it going? That's the velocity time graph, okay? Every second, how fast is the bicycle going, right? Now, question number 1 is, what is the meaning of velocity? Now, velocity, the actual sorry, the actual formula for velocity is actually displacement divided by time. Okay. Yeah, the actual formula for velocity is displacement divided by time. But yeah, we don't write divided by time. Okay, when we write our answer. Anything that's divided by time, right? We will use this word, rate of change. Okay, rate of change means divided by time. So displacement divided by time, rate of change of displacement. Okay, so like speed is distance divided by time. So we say rate of change of distance like that. Yeah. Okay, so what's the difference between velocity and speed? We've learned it before. Velocity is a vector quantity, speed is a scalar quantity. All right. So the only difference is that velocity has direction. Correct. Yeah, velocity is a vector quantity because it has direction. So speed doesn't care which way you're going. Velocity cares about which way you're going. Okay. So the first one, velocity is a scalar quantity, is not correct. It is a vector. Velocity has both magnitude and direction. Yes, okay, it has both magnitude and direction. Magnitude means how much. Direction means where. Okay. Velocity is a derived quantity. It's correct because derived quantity means you cannot measure one. You actually need to calculate it. Yeah, you have to calculate the derived quantity. You see, if you have a formula, most likely you are a derived quantity already because you have a formula to calculate your answer. Yeah, you can't really measure velocity. So it is a derived quantity. It needs to be calculated out. Okay. All right. Now, based on the diagram, state the movement, meaning how is it moving? Okay, how is it moving? State the movement of the bicycle for the following time periods. So from 0 to 5 seconds. Let's have a look. 0 to 5 seconds here. Okay, so first of all, you see the velocity, right? It's actually going up. Yeah, the velocity is actually going up. It's from 0 to 5. So 0, 1, 2, 3, 4, 5 lah. Now, if your velocity is increasing, we know that this must be a acceleration. Correct or not? Yeah. If the velocity is increasing, this must be an acceleration. Just like here, from here to here, it's also increasing velocity from 5 to 20. This is also acceleration. This is a deceleration because the velocity go from 20 to 0. Okay, so from 0 to 5 seconds, we know that this is a acceleration. Okay, I write at the back first. Okay, I write at the back first. So that's one thing. Okay, now, is the acceleration uniform or not? The answer is no. Because if you want to use the word uniform or you want to use the word constant, there must be a straight line. Okay, you see this part and this part and this part and this part, right? These four parts are all can use the word uniform or constant. Uniform what or constant what, I don't know lah. But they can use the word uniform because they are all straight line. This one, no straight line means not uniform. Okay, uniform means it stay the same. So it's not a uniform acceleration. Then what is it? It is either increasing or decreasing. Okay, if it's not uniform, it must be increasing or decreasing. So increasing or decreasing, you have to see whether the line is getting steeper and steeper or is getting flatter and flatter. Do you understand? Okay, you look at the line, is it getting steeper and steeper or flatter and flatter? So you sit on it. Let's say it's a roller coaster. All right, you sit on it. Then it goes like this. This is getting steeper and steeper. If it's flatter and flatter, it'll look like this. Like that. That's flatter and flatter. Okay? So if it's getting steeper and steeper, then it is a increasing acceleration. Okay? It is an increasing acceleration. So we can say that it is moving forward with increasing acceleration. Why moving forward? Because it's positive. Okay, positive means it's going forward. Because originally it was going forward already. Negative means it's going backwards. Okay, understand? All right. So for let's say for this 5 to 8 seconds okay, for this 5 to 8 seconds, right, we can say that it is moving forward because it's positive with uniform because it's a straight line, uniform. and it is accelerating. So moving forward with uniform acceleration. Does that make sense? So once you know the way to write, you know the tip, right? Then you can write for every section already. You don't have to worry about, oh, this, I don't know how to explain this. Fair enough. Okay, you see 8 to 15 seconds. 8 to 15 seconds, first of all, is it moving forward or not? Positive? Yeah? Everything above this line is positive, huh? Everything above this line is moving forward, huh? So yes, it is moving forward. It is moving forward with, okay, this, is it a straight line or not? It's a straight line, right? Yeah, this thing is about whether it's a straight line or not, or it's a curve. Curve, that means increasing or decreasing. Okay, if it's a straight line, then it must be uniform. Yeah, uniform. And then what is happening to the velocity? The velocity is decreasing. When the velocity is decreasing, we call that deceleration. Deceleration. The velocity is getting lesser and lesser. Okay? Yeah? Moving forward with uniform deceleration. Okay, what about this part? What about this portion here? Okay, you see this portion is in the negative side already, right? So if it's in the negative side, this must be moving backwards. Okay, this one is moving backward. Is it uniform? Yes, it's a straight line. It is still uniform. So moving backwards with uniform. Now this is an acceleration because the number is actually getting bigger and bigger from 0, 1, 2, 3, 4. So this is moving backward with uniform acceleration. Do you understand? Moving backward with uniform acceleration. Okay, get it, Anyone don't get this? Okay, let me know if you don't get it. Okay, what about the last part? The last part, okay, negative, right? So moving backward, lor. Moving backward, okay, with, is it a straight line? Yes, it's a straight line. Uniform, okay. Is it accelerating? No, it's not changing. The speed is not changing. It's not decelerating. So what is being uniform? Is the velocity being uniform. It's a constant velocity, right? So yeah, moving backward with uniform velocity. Okay, you get it? You understand? So any situation also you can write down what is happening as long as you just follow. Okay, positive means forward, negative means backwards. Straight line means uniform. Curve means increasing or decreasing, so on and so forth. Okay, yeah? Okay, next. Now you need to calculate the acceleration and the displacement. So for this one, right, you have to remember what is the SVA. Okay, remember this thing. It's up here also. It's in the short notes also. Yeah, SVA, right? You want to go down, you have to find the gradient. You want to go up, you have to find the area. Okay? So right now, they are giving us what? Right now, they give us the velocity, which means they give us the V. Okay? If I want to find the acceleration, I have to get the gradient. Okay, so this acceleration is the gradient. Okay, now what about if I want to find the displacement? The displacement is the S, then I need to find the area. Okay, yeah. So if you do gradient from 5 to 8 seconds, 5 to 8 seconds means I just want the gradient here only. Okay, I want the gradient here. All right. So you mark down the 2 points. This is 5, 5. And then this is 820. Okay, 5, 5 and 820, the coordinates. Then you can do y2 minus y1 over x2 minus x1. Okay, So 20 minus 5 over 8 minus 5. Right? This is 15 over 3. 15 over 3 is of course 5 lah. Okay, 5. Then because it's an acceleration, right? Then you know the units for acceleration, ms -2. Okay, meter per second square. You don't need to know how you get the units. As long as you see acceleration is gonna be 5 meter per second square. Acceleration must be meter per second square. Okay, can? All right, next one. The area from 5 to 20. Area from 5 to 20 means from here to here. Listen, this to this. Okay, so it's up to you lah. If you know how to do the trapezium, then go ahead. You can do trapezium here. Okay, and then this is a triangle. One triangle here. All right, and then you can either do the whole trapezium together or down here, or if you don't know how to do the trapezium, then you do triangle and rectangle. Okay, yeah, so I just have to add up all the areas together. Okay, so for this one, let's say I do triangle and rectangle. So this triangle is half times the base, which is 3, 5 to 8 ma. 5 to 8 is 3 ma. Times the height is 15. 5 to 20 is 15. Okay, so half, this is this part. Okay, so that's half times 3 times 15. Okay, plus the rectangle down there. Okay, the rectangle down there here. This is 3 and 5. Okay, so 3 times 5. Okay, plus this big triangle. This big triangle here. So 8 to 15 is 7. And then 0 to 20 is 20. So 7 and 20 up. Okay, so this big triangle is half times 20 times 7. Okay, half times 20 times 7. Right? And then you have this blue triangle here. Okay, from 15 to 18 is 3, and then this part is 4. Now you could just put -4 if you want. Yeah? Because right, displacement got -1. Displacement got direction also. So these two at the bottom, right, eventually they will be negative number. Okay, so if let's say you want to be you want to just like make it more straightforward, right, then you just use back negative. So then you don't have to think this one should be negative or not, this one should be negative or not. Okay, no need to think about that. If it's displacement, right, you just use back -4, then you just times -4. Okay, so this will be, this is a triangle at the bottom right. So this is half times -4 times 3. And then plus the last one, the orange one is 2 and -4. Okay, so 2 times -4. Okay, now anyone don't know where I got these numbers from or not? Yeah, you have a good look. Let me know if you don't know where I got these numbers. Okay, now, can I? Yeah, then you just do everything lah. Yeah, just solve for everything. All right, half times 3 times 15 is 45 divided by 2. 45 divided by 2, 22.5. 3 times 5 is 15. Yeah. Half times 20 is 10. 10 times 7 is 70. Half times -4 is -2. -2 times 3 is -6. And then -8, right? Yeah, just double check whether your number is same as mine, because I'm not using calculator, so I don't know whether it's correct or not. Okay, so add up everything together. What should you be getting? What is your area if you add up everything together? 93.5 meters. Okay, yeah, everyone, make sure you get the same answer. 93.5. Okay, get or not? Can? Yes, no? Anyone cannot get this? Oh, okay. Give me some response. Yes, no? Okay or not? Yeah, can I? Okay, right. So yeah, that is how you do the motion graph question, Okay, so remember this SVA, very important, this one. Okay. All right, now, for the essay later lah, okay, that part, the last part of our seminar, then we will do the essay question. Okay, right? Now, this one, question F. So we have a cyclist here and a bicycle total mass 95 kg going up the hill, which is 10 meters high, then cycle down to point N. Okay, this is not really part of the motion graph, but it's just a what do you call this? It's just related part of motion only lah. It's just a related question for motion only. Yeah, we didn't really learn this in class, but you are supposed to have learned this last time already about energy. Okay, so for those that forgot, just to recap, what is gravitational potential energy? Is when you leave the ground. Whenever you leave the ground, right, you will gain GPE. You will gain gravitational potential energy because you are ready to fall down. Anything that is lifted above the ground is ready to fall down. So it must have GPE inside. Okay? So the way to calculate GPE is by using this formula, mgh. Okay? So your mass, let's say, is 95, given in the question. The G is, of course, 9.81, and the H is the height. The higher up you bring an object, the more GPE it will have. Okay? So the height here will be 10 meters lah if you go up to the highest point. Okay, so what is 95 times 9.81 times 10? Okay, you should get 9319.5 joules. Okay, 9319.5 joules. Okay, so that is GPE, gravitational potential energy, which is when you leave the ground. Okay, now as you come back down towards the ground, let's say the cyclist come back down towards the ground, he will lose the GPE. Okay, he will lose the GPE because if you are on the ground, you don't have GPE one. You must be away from the ground, only got GPE. Okay? So when you come back down, you will lose your GPE. But this GPE, it's not going to just disappear, you know? Yeah, it's not going to just disappear. It will convert into some other energy. Yeah, in this case, it will convert into kinetic energy. Okay, because as you go from here and you just slide down, you are gonna get faster and faster, right? Yeah, even without cycling, you will get faster and faster because as your GPE starts to get lower and lower, your kinetic energy starts to become higher and higher because it transfers. The GPE transfer into kinetic energy. Do you understand? So once you're at the bottom, all your GPE would have disappeared already. All of it would have transferred into kinetic energy already. Do you understand? So we can say the GPE has transferred into kinetic energy. And we know GPE is 9319.5. Kinetic energy, the formula for kinetic energy is half mv squared. Okay, that's the formula for kinetic energy. Half mv squared. So half 95 v squared. Okay, yeah, 95 v squared. So then you can get v squared is equals to what? And then you can find v. Okay, v squared will be cut times 2, 98.1 times 2. I think this is v squared lah. 196.2. Yeah. Okay. Then your V will be 14. 14.007. 14 lah. Okay. 14 meter per second. Okay. Can? Now, in real life, right? Of course, not all the GPE will be converted to kinetic energy. Because in real life, every time you want to transfer energy, some energy will be lost one. Okay, some energy will be lost. So, for example, supposedly all the GPE from your bicycle will become the kinetic energy of your bicycle. But in the middle, you will lose some energy. In real life, you will lose some energy. Why that? Because there's things like friction. There's things like air resistance that will cause you to waste your energy to fight them. Yeah? So in real life, you don't have a perfect transfer one. So what is the assumption we did for this? We assume what? We assume that all GPE become kinetic energy. Why then? Because we assume that there is no energy loss. There is no energy loss in the process. Okay? We assume that there is no energy loss in the process. Okay, understand? But that is in a perfect world only lah. In real life, it doesn't happen. Okay? All right, any questions about motion and motion graphs? Any questions about that? Otherwise, we're gonna head into part 2 of our seminar, which is a momentum questions. Okay? Yeah, momentum questions. So you go to page number 9. Go to page number 9. Okay, so diagram 4.1 shows a space vehicle moving at 0.5 meter per second, about to dock with a space probe moving in the opposite direction. So they drew for you already lah, huh? This thing moving here, this thing moving in opposite direction. Okay, the mass of the vehicle and the probe are 2500 kg. and 1500 kg respectively. Okay? After the docking means after they connect together. Docking means they are parking. Yeah? Docking means like parking. So after the docking procedure, the space vehicle and the space probe move together at 0.2 in the original direction of the space vehicle, meaning like this. Okay? After they combine together, both of them move together this way. Okay? What is the collision that occurs in diagram 4.2? Now we have three kinds of collision. Okay? The first kind is called elastic collision. Elastic means that it'll bounce one, right? Boing, boing like that. That's elastic. So you hit, right? Boing, boing, they will bounce apart. That's elastic. And then we have inelastic, which is when they hit each other, there's no bounce. They will stick together. So after they hit each other, they will stick together. That's inelastic. And the last one is explosion. When you put them together at the start, and then kaboom, they split. One go left, one go right. That's explosion. Okay? So this one here is considered inelastic. Because when they stick together, then they just stick together. When they hit each other, they just stick together. So you can say it's inelastic. Inelastic collision. Okay? Yeah. Okay, based on the information provided, calculate the total momentum of the system. Okay, so what is the total momentum? Total momentum means this person's momentum plus this person's momentum. Correct or not? Yeah? Momentum of the vehicle plus the momentum of the space probe. Okay, that's the total momentum. Momentum of vehicle plus momentum of space probe. Okay? Now, how to calculate momentum? Momentum is mass times velocity. Okay? So m1 v1 plus m2 v2. Okay? Mass times velocity, mass times velocity. Okay? Now, you know what's the mass of this thing, right? It's 2,500, right? Okay? And the mass of this other thing is 1,500, right? Okay, you know the mass. But you know this velocity, you don't know this velocity. What? How like? You see, you got 0.5, but you don't know what is this velocity. They never give you. What is the velocity of this guy? They never give you. So how? Never mind. We look at this. We look at after they dock. This is before they hit each other, ma. This is after they hit each other, ma. So we look at after they hit each other. After they hit each other, right? Both of them are moving with the same velocity. Agree or not? Okay? The space vehicle and space probe move together. So both also 0.2. Okay? Both also 0.2. Do you understand? Yeah? So how much is it? 2,500 times 0.2 plus 1,500 times 0.2. How much? This is the same as 4,000 times 0.2 lah. Plus. Okay, 800, yeah? You should get 800, Okay, 800 momentum. What is the units for momentum? It is kilograms meter per second. Why? Because kg is for mass, meter per second is for velocity. So mass times velocity, kg meter per second. Okay? Now, once you know the total momentum, okay, once you know the total momentum, you can calculate what is the speed before docking. Okay, you can calculate the speed before docking. You know why? Because according to a certain law, right, the total momentum must always be the same one. Okay? According to a certain law, according to a certain principle, total momentum must always be the same. Meaning here, your momentum add up together is 800. That means here, your momentum add up together must also be 800. It must be the same. Do you understand? Okay? The total momentum must be the same. So if let's say I write M1U1 plus M2U2, this is the total momentum before anything happened. Okay? Total momentum before anything happened. This must be equals to M1V1 plus M2V2. This is the total momentum after the docking. Do you understand? They must be the same. Total momentum before must equal to total momentum after. And we already know the total momentum after is 800. We have already calculated this already. So the total momentum before, 2500 times 0.5, right? Okay, mass times velocity. And then 1500, but I don't know what is the initial velocity of the other thing. I don't know what's the initial velocity, so I'm just going to try to find u. Okay, Ken? Do you understand this or not? You must understand this. This is the most important formula in momentum. Okay, M1U1 plus M2U2 equals M1V1 plus M2V2. It tells us that the total momentum must always remain the same. Okay, so how much is U2? You are supposed to get a negative number because 0.5 is positive to the right. So this one to the left must be a negative number. Okay, you're supposed to get a negative number. Negative 0.3. Anyone cannot get negative 0.3. Okay, all good? All good? Okay. All right. So what is this law that says that the total momentum and the before and after must be the same? What is this law? This is actually the principle of conservation of momentum. Okay. Principle of conservation of momentum. All right, that is the principle involved lah. Now you got to explain. All right, ready? They will ask you for explanation lah. But if let's say they ask you to explain, you must tell them lah. The total momentum, before collision is equal to the total momentum after collision. Right? That's what I've been saying, right? The total momentum before anything happened must be the same as the total momentum after anything happened. Okay? If there's an extra part lah, there's an if actually. If no external forces, meaning there's no other people suddenly come in and push you. Okay? If let's say suddenly got someone come and push this thing, then of course different already lah. Right? So this is if no external forces acts on it. Okay? If no external forces acts on it, means no external forces come in to push or pull. Okay? Can? Right? Now, describe the propulsion. Propulsion means shooting, flying, like why the rocket can shoot. Okay? Describe the propulsion of a rocket in terms of momentum. So for momentum question, they will always have this explanation question, 4 marks explanation question, asking you to explain why can this thing work? Why can the rocket fly up? Why can the jet engine move forward? Why can the squid move forward? Why can the bullet, when you fire a gun, the gun will move backwards? All these explanation question, right? The way to answer is always the same. You just have to change a few things only. Okay? So you have to remember the template. The way to say it is you must remember to tell them if something goes in front, something must go back. If something goes to the left, something must go right. If something goes up, something must go down. That is the principle of conservation of momentum. Okay? So you say okay, first of all, right, the rocket shoots what? The rocket shoots out hot gas. Okay? You can tell them how to get the hot gas also. That's not really important lah. You must tell them there's hot gas coming out lah. But as an extra, I will just tell them how to get the hot gas. Okay? So I can say the rocket burns fuel and produces hot gas. Okay, this is just extra only lah. Okay, this is just extra only. Okay, now is the important part. Okay, so you say hot gas moves which way? Hot gas will be shooting down, correct not? Hot gas moves downward at high velocity. Okay, the hot gas shoots down. It shoots down very quickly. Okay, moves downwards at high velocity. This produces a large downwards momentum. Okay, if you go downwards, of course, you have a downwards momentum lah, correct or not? Yeah, you are moving downwards, then you have a downwards momentum lah. Okay, now according to principle of conservation of momentum, according to the principle of conservation of momentum, okay, there must be, I said just now, if something goes up, something must go down. Something go left, something must go right. There must be an equal but opposite. Okay, there must be an equal but opposite upwards momentum. If there is downwards, there must be upwards. So then something must move up, lor. So who move up? Therefore, the rocket moves upwards. Okay? That's it. That's how you explain why the rocket can fly up. Okay? Why the rocket can fly up. Again, this applies to everything. All explanation also you can use the same template. You just have to change these few things only. You just have to change the thing and the direction. Okay? Change the direction, change the direction, change the object, change the direction. Okay? Yeah? So if let's say I have a gun shooting a bullet, they ask you why the gun will move back. So you tell them the bullet move forward at high velocity. This produces a large forward momentum. According to the principle of conservation of momentum, there must be an equal but opposite backward momentum. Therefore, the gun moves backwards. You see? All kind of explanation also you can use the same template. If they ask you why the squid can move very fast away from his predator. So you say, the squid shoot what? The squid shoot out ink. Okay? So ink move backwards at high velocity. This produces a large backwards momentum. According to the principle of conservation of momentum, there must be an equal but opposite forward momentum. Therefore, the squid moves forward. Do you see? Only the highlighted part need to change only. Everything else remain the same. Now, of course, distance is only for rocket only. Distance, yeah, for other things, you don't have to write this. Okay? But everything else, you just have to follow exactly like that. Can or not? Clear or not? Okay? Yeah, very easy, right? If you just stick to this thing. Okay? Right? So same thing lah. You see, they ask you to explain the working principle of a jet engine. Okay? So jet engine shoot what? Jet engine shoot hot gas. Okay? So you say hot gas moves backwards. Okay? Hot gas moves backwards at high velocity. This produces a large backwards momentum. According to principle of conservation of momentum, there must be equal but opposite forwards momentum. If there's backwards, there must be forward. Therefore, the plane, because the jet engine is connected to the plane, okay? Therefore, the plane moves forwards. Understand or not? This one. Yeah, can or not? Do you think you can write this yourself later? Yeah, without looking at the answer. Okay, just remember, if something go up, something must go down. You just remember this. Okay? All right. Now, you look at page number 11. Okay, page number 11 down here. So we have a rocket pushing the exhaust gas out 100 kilogram in 1 second, velocity 200 meter per second. Mark and name the two forces acting on the rocket. Okay, so what are the forces acting on the rocket? We have something that pushes the rocket forward. Okay, this is what we call thrust. Anytime you have an engine or whatever pushing you forward, we call that thrust. Okay, the engine making the car go forward, thrust. The jet pushing the plane forward, thrust. Okay, anything forward is called, anything pushing you to move is called thrust. Now, if there's something going forward, there must be something going back. That something going back, right, is actually air resistance. Air resistance stops you from going forward. Now, we can call that drag. Drag is another word for air resistance. Okay, so we have thrust going forward and drag going backwards. Okay, so what is the momentum acting backwards? The momentum acting backwards is mass times velocity, which is 100 kg times 200, 200, 00. Okay, so then what is the momentum acting forwards? If you know the momentum acting backwards, you're going to know the momentum acting forwards, right? Okay, because it will be the same thing, right? The momentum will be 2, 0, 0, 0, 0. Okay, forward and backward is the same. Yeah, forward and backward is the same. Okay, can? Right? Okay. This one should be no problem already. Okay, so any questions until here so far? Any questions until here? Okay, no problem. Okay, so if no problem, right, then we are going to let's take a short break first, okay? And then later we will do this question on page number 13. This is about the I said impulsive force and the what do you call this? Suvat question lah. Okay, just a very quick question with all these things here. Okay, impulsive force and Suvat. Okay, right? And then if we have time, maybe I'll do a bit of ticker tape as well. Okay, before we go into our last part, which is essay question. Okay, so we're gonna take a short break, just 5 minutes only, and we will be back at 10:59. Now it's 10:54, right? Okay, I'll see you guys again in 5 minutes. Okay. Okay, welcome back. All right, let's continue. Okay, so like I said, page number 13, question number 6 here. So we have a watermelon falling off from a 2.5-meter tall table. Well, 2.5 meter is actually very tall. Okay, even I am only less than 2 meters. I am only 1.8 meters only. 2.5 meter is like 1 story tall already. Yeah, this table. Okay, so what is meant by free fall? So free fall means what? Free fall means you fall down due to one thing only, due to gravity only. Okay, so you can say object falling under the effect of gravity only. Okay? Object falling under the effect of gravity only. That is called free falling. Okay, so nothing else is pulling it, nothing else is pushing it, just the gravity. Next, they want you to calculate the time taken for the watermelon to reach the floor. Now, usually if there's time taken for falling or whatever, it's usually a Suvat question already lah. Okay, so we start by writing down our Suvat first. Okay, so S is how far are you going to fall? Okay, that's the S. How far do you fall? So it's going to be 2.5 meters. Okay, 2.5 meters. All right. And then the U, initial velocity is before you fall, ma. Before you fall, you are not falling, ma. Correct or not? Yeah, before it starts to fall, you are not falling. So the initial velocity is 0. Okay, initial velocity is 0. And then your final velocity, I don't know. Yeah, I don't know what's the final velocity at the end of my fall. Okay, like towards the end. But A, I know. A is the acceleration. And you see, if you fall down due to gravity only, your A is going to be what we call the G, which is 9.81 on Earth. Okay, only on Earth is 9.81. Yeah, you go other planets, your A is going to be different, your G is going to be different. Okay. Now, what about the T, the time? That's what we're trying to find out. So we have SUA plus the thing that we are trying to find, which is T. Okay, so you're going to be using your Suvat equation, which is S equals to UT plus half AT squared. Okay. Now I know most schools, their first term exam, they don't give formula sheet one. From what I know lah. Okay. Most schools, the first term exam, they don't give formula sheet. So I suggest you memorize these four formulas. And then the moment you go into your exam, you just write everything down first. Okay. Once you enter, you just write everything down first. Okay. Yeah. Because I know most schools they don't give formula sheet one for the first exam. Okay, so you use this formula, you put in everything. 2.5 equals to 0 times t plus half 9.81 t squared. Okay, 0 times t is gonna be 0. This one's gonna be disappear. This one. So you get t squared and then you're gonna get t, which is how long? Okay, everyone got 0.71 seconds. Yeah, anyone didn't get this? 0.71. Okay, then calculate the velocity of the watermelon just before hitting the floor. So the velocity, like when the watermelon drop, right, just before hitting the floor, that's actually the final velocity. Okay, that's the final velocity of the falling. So I want to find S U A and then I want to find V. Okay, yeah, I got these three and I want to find V. So you can use this formula. V square equals to U square plus 2AS. Okay, now why don't I use the T? Because we try not to use the things that we found. We try not to use our values because you are not sure whether your value is correct or not. Yeah, like during your exam, maybe your value might be wrong. So try to use the ones that are given to us already. That will be much better. Okay, so V square equals to 0 square plus 2 times 9.81 times 2.5 meters. Okay, you're gonna get the V square and then you can get the V. Okay, if anyone is having any trouble with the calculation, let me know. 7, yeah, okay, do you all get 7? 7 meter per second, yeah, 7 ms negative 1. Yeah, now the watermelon hits the floor surface and breaks upon landing. What is the change of momentum of the watermelon? Okay, change of momentum means what? Change of momentum means your momentum just now it was 3. Now your momentum is 8. So the change of momentum is 8 minus 3 lor, which is 5 lor, correct or not? You take your momentum now minus the momentum just now. Okay? So you take your final momentum minus the initial momentum. Agree or not? That's called change of momentum. Okay? Final momentum minus the initial momentum. Okay, so the mass of the watermelon is 1.5 kilograms. Now, this U and V, you have to be very careful, okay? This V is the final momentum after landing, after it hit the ground, okay? You see, this part is what we call the landing part. This part is what we call the falling part. This V and this V are not the same V. Do you understand? Okay? Because this part is the falling down right before it touched the ground. Right before it touched the ground, that is your final velocity of the falling. But for the landing, this is actually just the start of the landing, right? Do you agree or not? The final part of your falling is actually the start of your landing. So whatever you find here for the final velocity, this is actually the initial velocity of the landing. You understand? It's actually the first part of your landing. Okay? So the final part of your falling down is the first part of your landing, of you hitting the ground. Because after you hit the ground, your velocity will be zero already. So the final velocity when you hit the ground is zero. Okay? Final velocity when you hit the ground is zero. That's the V. All right? So then you can calculate this. So this will be 0 and then 7 times 1.5 is negative 10.5 lah. Does that make sense or not? Yeah? Okay? Anyone don't understand this? Anyone having trouble understanding about the final velocity and the initial velocity? Can use NS. Better don't use NS because that's not the SI units. It's not what we normally use. So we stick to SI units will be better. Yeah. Even if you do force times time, right, for the change of for the impulse, you should also use kgms -1. Okay, next. Now, take the correct statement about the impact time between watermelon and the floor. So when the watermelon hits the floor, the impact time is gonna be very short. Okay? This impact time depends on what? This impact time depends on the surface one. Yeah, so when you hit something hard, your impact is gonna be boom. That's it. Boom. 1 second. But if you hit something soft, like a cushion, your impact time is going to be doing like that. Okay? So it's going to be a longer impact time. That's why when you hit a cushion, it doesn't hurt. Because when you hit the cushion, the impact time is doing longer. And according to the formula for impulsive force, the longer the impact time, okay, the shorter the impulsive force, the smaller the impulsive force. But right now, if you hit a hard floor will have the shorter the impact time, the bigger the force. Yeah, right now, if you hit a hard floor, the shorter the impact time, the bigger the impulsive force. But if you hit a cushion, the impact time is very long, the smaller the force. Okay? So why would the watermelon break? Because you can say the impact time between watermelon and hard floor is short. Okay? Then you can also say the watermelon has high mass and falling at high velocity. Okay, so you see, these three things are short time, the mass is high, and the velocity is high. The falling velocity is high. So all these combined, right? This results in a high impulsive force. Okay, all these things combined, you get a very, very high impulsive force, which will cause it to break lah. Okay, which will cause the watermelon to break. Okay. So you have to tell them it breaks because of the high impulsive force, but you also got to tell them why did it have high impulsive force? It's because of the short time and the high velocity and the high mass. Okay. All right. Next part. Okay. Next one, I'm going to go into some ticker tape question. Okay. So after the ticker tape question, then we will do the essay questions already. So you go to page number 19. Page 19. Okay, so this is a ticker tape graph, and you can see that the graph is getting shorter and shorter and shorter. When the distance between the dots are getting shorter and shorter, that means you're becoming slower. Okay, when the dots are far apart, this is fast. When it's close together, it is slow. From fast to slow, we can say that this thing is decreasing velocity, or this thing is decelerating. You understand? So you say deceleration. Okay? Now, if you connect the first dot of everybody, you can see that the line is actually a straight line. So you can actually even say this is uniform deceleration. Okay, it's uniform deceleration. Okay, next, what is the time taken for one tick? Okay, so the time taken for one tick, you can see 50 hertz, right? Yeah, we know that 50 hertz means what? 50 hertz means that 1 second, there's 50 ticks. So one tick will always be 1 divided by 50, 0.02 seconds. This is a standard number. Okay, standard number. You just have to remember this. Okay, now, why must the ticker timer connect to AC supply? This ticker tape, it doesn't work with DC one. Okay, it doesn't work with DC. It only works with AC. And the reason is because AC, the current keep changing direction. And if the current keep changing direction, only your ticker timer can go up, down, up, down, up, down, up, down, up, down like that. The thing goes up, down based on the electricity direction. So you keep changing, they go up, down, up, down, up, down. Okay? So you say to produce a continuous ticking motion. Ticking is tick, 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 tick lah. Yeah, to produce a continuous ticking motion. Means it can keep ticking, 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 ticking. Okay. All right. So now you have to calculate the acceleration and deceleration of the trolley. Okay, so to find acceleration and deceleration, you need to find what is u and v first, the initial and the final velocity first. Okay, initial you use the first row, final you use the last one. Okay, so the initial one, this is okay, by velocity is distance over time, right? Or displacement over time. Okay, yeah, displacement over time. So the displacement for the first strip is 10 centimeters. Okay, 10 centimeters divided by What is the time taken? You can see this one got 10 ticks. I don't even need to count. Each strip, they already tell me got 10 ticks. So 10 ticks means 10 times 0.02. Okay? Yeah, 10 times 0.02. So this one will be 50 because the 10 and 10 cancel each other out. 1 divided by 0.02. Okay? Now, you can use cm per second, okay? For ticker timer only. For ticker timer only, you can use cm per second. Okay? Now, what about the final one, the final velocity? This is 2 cm. Okay? Divided by also 10 ticks. You don't have to go and count. Okay? They say each one is 10 ticks means every strip also 10 ticks. So this is 2 divided by 0.2, which is 20 divided by 2 lah. 20 divided by 2 is 10. 10 cm per second, correct? Okay? Then acceleration is v minus u divided by t. 10 minus 50 divided by, okay, this is where many students get it wrong. The t for acceleration. The t for acceleration is how long from initial to final. Okay? How long from your initial to final? Initial is this whole thing. Final is this whole thing. So from initial to final is 1 jump, 2 jumps, 3 jumps, 4 jumps. Okay? But you need to remember something. This 1 jump is not like that, you know. This 1 jump is not 0.02 seconds. This 1 jump is jumping the whole strip already. You jump again, you jump the whole strip already. It's basically skipping the whole strip. So every time you jump is 10 ticks already. You understand? So 4 jumps means 4 times 10 ticks. Okay? 4 times 10 ticks, and every tick is 0.02. You get it? Yeah, because when you jump, you're jumping over the whole strip. So you are jumping 10, 10, 10 every time instead of 1, 2, 3, 4. Okay, so how much is this? How much is the acceleration? Negative 50? Then what got negative 50 and negative 2 one? This is negative 40 on top, and then divide by 40 times 0.02. 40 times 0.02. So supposed to be this and this and cancel lah. It's supposed to be negative 50, okay? It should be negative 50. MS negative 2 for acceleration. Okay, MS negative 2 for acceleration. Now, negative is deceleration is correct lah. We already said it was going to be a deceleration. Okay? Can I? Right. Now, what about the average velocity? Velocity is displacement over time. So like I always say, average means total over total. Okay? Average velocity means total displacement over total time. So you know how to get the total displacement or not? You just have to add all the displacement together lah. Yeah? Add the displacement of this and this and this and this and this. So you 10, 8, 6, 4, and 2. Okay? And then what about the total time? Now, this total time and this time are different. Okay? This acceleration, right, is from here to here. How long, correct? For acceleration, the t of acceleration is from u to v. Okay? But the total time, total t is from the first dot to last dot. Different one. Is different one. From the first one to the last one is how many jumps. So this whole thing is 10 times 0.02 ma. This whole thing is 10 times 0.02 ma. This whole thing also, this whole thing also, this whole thing also. Total got 5 strips. Okay? Total there are 5 strips. So it is 5 times 10 times 0.02. Okay? Instead of 4 times 10 times 0.02. Do you get it? It's different enough. It's different enough. Okay? Yeah, so how much is the average velocity? Okay, 30. You'll get 30 meter per second. Yeah, 30 meter per second. Okay, so that is average velocity, right? Remember, total distance or total displacement over total time. Okay, so any questions up to here? Any questions? Oh, sorry, you're right. All of it should be cm per second. You see, even I will make this mistake because I'm too used to using meter per second. All of it should be cm per second one. Cm per second square as well. All should be cm per second, not meter per second, not meter per second square. Cm, you're right. Okay, see, even I will make this mistake sometimes. So you must be careful. For it, we use cm per second or cm per second square. Okay. All right. Any questions up to here? Any questions? If not, we will go on to our final part. Okay, the final part of today's seminar is we will look at essay questions. Now, essay questions are these kind of questions where they ask you to choose which version is the most suitable, or what kind of modifications should you choose to make it most suitable for something. All right? It could be choose the most suitable bicycle for a competition. It could be most suitable wheelchair for athlete. It could be a most suitable jet engine. It could be a most suitable oil tanker, petrol tanker. Yeah, all this kind is called essay question. Okay. Now, This essay, right, I always tell my students, it's all about common sense. Okay, it's all about common sense. But the thing is, you need to get that common sense first. Common sense is not you born with it, you know. You have to gain the common sense. Just like for you, it's common sense that when you have a water bottle, you twist clockwise to close the bottle, you twist anti-clockwise to open the bottle. That's common sense to you, right? But did you born with that? Were you born with that information? No, you had to learn that. Then for now, for you, it's common sense. So it's the same thing for this essay question. The more questions you read, the more answers you read, the more you will get that common sense. Okay, yeah. To me, of course, I know I should always choose iron instead of steel. But to you, it might not be common sense to you. Okay, so it's stuff like that, right? It's stuff like that that you need to learn it. Then you realize, hey, every question they're asking the same thing. I knew this. I knew this from another question. I learned this before from another question. Then you know it. Okay? Yeah, so that is how you solve these essay questions. You just got to read more, just got to do more only. Okay? Now, in your exam, you can write the answer in a table. You don't have to write it in a paragraph form. Of course, you can write it in a paragraph form. You can say, you should choose this, because this is your reason. You should choose this because this is your reason. You should choose this because this is your reason. Sure, no problem. But you can also write it in a table. We are always going to write it in a table, okay, in our book. So the table on the left side, right, will be the characteristics that you choose. And on the right side will be the reason. Why did you choose these characteristics? Okay, yeah, why did you choose these characteristics? All right, so now let's have a look. So the first thing you're gonna read is, what are we trying to find? Like what is this for? So this is for what? This is for cycling, track cycling. It's a competition. Competition for a cycling competition inside a track. It goes around and round and round and round. Okay, yeah. So you have to choose which bicycle is the most suitable. Okay, there are a few things here. Now, the first thing you're going to choose is the body. Do you want the body to be made of alloy steel or the body to be made of carbon fiber? Alloy steel means it's a steel, but you mix it with other things to make it stronger. That's called alloy. You learn in chemistry, right? So the other thing is carbon fiber. Now, again, common sense tells me carbon fiber is the best. But you probably never heard of carbon fiber before. Okay? Yeah, some of you probably never heard of carbon fiber before. It is a very special material. Okay? You will see this pattern. Sometimes you see this kind of pattern. It's carbon fiber pattern. Okay, it's carbon. As we know, carbon can be very, very strong. Diamonds are made of carbon, right? And the thing about this carbon fiber is that it is super light as well. Okay? It is super light. So you have something that's super strong and super light. Isn't that the best combination? Yeah? F1 cars the entire F1 car is made of carbon fiber. Okay? Anywhere they can put carbon fiber, they will always put carbon fiber. Okay? So like this kind of racing bicycles, these track bicycles, they are always made, I mean the most expensive ones, the most high-end ones, they are made from carbon fiber. You can actually lift them up with just one finger. Yeah, just one finger, shoop, you can lift the whole bicycle up. That's how light it is. Okay, so if you get to choose the material, carbon fiber is always one of the best choices because it is very lightweight and it is very strong. Okay, yeah, very lightweight and very strong. So you're right lah. Body made of carbon fiber. So you say that it is lightweight, it is lightweight and strong. Okay, it is lightweight and strong. Okay, now the next one is the handle. You have a choice between a drop handle where the handle drops down like that, okay, or a straight handle. Okay, a straight handle. Now, this handle, right? Again, racing bicycle. You look at this racing bicycle, look at the handle. Look at the handle. It's always like that one. It's always drop down like that one. Yeah. The cyclists, they hold like that. Instead of like our normal bicycle handle when it's straight like that, you ride like that. You hold like that and you ride like that. Okay, no, that one is you grip onto the side like that so that the person will bend down. Okay, yeah. So all this, right, is to make sure that you will reduce the air resistance. Because when you grip like that, you will automatically bend down one if you grip like that. Our normal straight bicycle, straight handle, you won't bend down like that because it's too hard already. You will hold it like that, where your body is straight up. But if it's grip on the side like this, if it's drop handle, you will grip it and then you can bend down easily. Okay, you will bend down easily. Yeah. So we use a drop handle instead of a straight handle. Because like that, you can reduce air resistance. Okay, how does it reduce air resistance? Is it makes sure the driver, oh sorry, it makes sure the rider or the cyclist is bent down, can bend down easily. Okay, because you try like you try your hand like that, right? You put your hand like a normal bicycle handle, and then you try to bring your hand like that close. You try to bend down like that. It's very hard one. It's very hard to bend like that one. But if you have like that, if your hand is like that, instead of like horizontal, it's vertical. It's much easier to bend. You can see the difference. It's much easier to bend up like that. Compared to this, you try to bend, it's very hard. You can try it. Okay. All right. Next one is the tire. The next thing is the tire. Now the tire you have a choice with. You see, there's white tire without, white tire with tread, narrow tire without, narrow tire with tread. So you have to choose between two things first. Wide or narrow first. You have to choose wide or narrow tire first. So again, if I open up the picture for you, I don't know whether you can tell from here lah. But the tire is actually very, very thin, very, very narrow. Okay, I can't. Okay. This picture you can tell. You can see here. Look at this tire. It's different from your normal bicycle tire. Okay, this bicycle tire is super, super narrow one. Super, super narrow. Okay, so why that? Narrow tire. Because, right, if you have a narrow tire, your pressure is going to become higher. Okay, why? Pressure is force over area. The smaller you are touching, the smaller area you touch the ground, okay, the smaller area you touch the ground, the bigger the pressure. Okay, your tire will actually press onto the floor harder. Okay, so you can say greater pressure. Okay, greater pressure on the floor. Greater pressure actually give you more grip lah. Yeah, greater pressure will give you more grip. Okay, and the last one is the tire with tread or without tread. Now this one I mentioned in class before. So the treads on the tire, right, is actually useless unless it rains. Okay, the tread on the tire is useless unless it rains. Again, if you refer back to F1 tires, okay, during dry time, they only use the first 3 tires, which is no tracks. Only if it rains, they will use the 2 tires at the back, the green and the blue one, because that one got track. Okay? So your competition is indoor competition one. This is an indoor track. It will not rain. So you don't need any tracks because the tracks will make you slower. Okay? So we will choose tires without track. Because no track will actually give you more contact, better grip. It will give you better grip. Yeah, there's more contact with the floor. Okay? So now you have 1 mark, 2 mark, 3 mark, 4 mark, 5 mark, 6 mark, 7 mark, 8 marks, right? If you make the right choice, you will get the marks for the choice. Even if your reason is wrong, also never mind one. If your choice is correct, you will get marks for the choice already. Okay? So every time you should at least get correct for the choices. Even if your reason you cannot think of it, never mind. Okay? Now, this question is 10 marks. So now you have 8 marks, ma. The last 2 marks is your final choice. So let's see. We have a carbon fiber body. We want a drop handle. We want a narrow tire. And we want without tracks. So our best choice that hits all criteria is track bicycle R. So this is how we write it. Track bicycle R is most suitable. Okay, track bicycle R is most suitable because it has all the criteria we want, ma. Correct or not? For example, because it has body made of carbon fiber, drop handle, it has a drop handle, it has narrow tires, and it has tire without treads. You get it? You chose the R, you have to give them a reason also. You choose the R, that's 1 mark. The reason for choosing the R, that's the final mark. So 10 marks in total. Yeah, 10 marks in total. Do you understand? Okay, can okay, now let's go on to another question. This one you never copy finish also never mind lah. I just need you to know why, how to write on it. Okay, let's go on to the next question. This is on page number 8. Page number 8. Okay, now this is not a normal wheelchair. This is a wheelchair used for what? This is a wheelchair that is used for a disabled athlete. Means what? It is for sports, for sports like the Paralympics. Okay? So this sports wheelchair is a bit different from your normal wheelchair. You can see this design also, you know already. The wheels are not straight one. The wheels are like angled out. Okay? So we're going to choose the most suitable wheelchair for a sports event, for an athlete. So again, on the left, we have our characteristics. On the right, we have our reason. Okay? Now, for the diameter of tire, we should choose a small or big diameter of the tire. Diameter means this. Basically this. We want the tire to be big or tire to be small. So we actually want the tire to be bigger. Okay, big diameter of tire. You will never find wheelchair with small tire one. Okay, why wheelchairs all have big tire? And if you use it for sports, right, your tire is even bigger than the normal wheelchair tire. So the reason why the tire needs to be big is so that you can actually move faster. Okay, the wheelchair can move faster. Okay, why? Because a small tire, if let's say the tire spin one full round, one full circle, you might end up until here if it spins one full circle. But if you have a big tire and you also spin one full circle, your tire will reach here already. You will be here already. Do you understand? If you spin one full circle like that, you will go all the way until here. So same thing, one full circle, but the big tire can go further. Okay? Yeah, so of course we want to choose a bigger tire. Okay, the next one will be the width of the tire. Width of the tire means this part here. Okay, how thick you want the tires to be, like that or like that. Okay, it's like, I mean, like that or like that, very narrow tire, narrow width. So it's the same as the bicycle just now, right? Okay, actually we want it to be a narrower tire. Narrow width of tire. But actually, right, the reason is a bit different for this. Now, for wheelchair, your tire is on left and right. When you want to turn the wheelchair, okay, when you want to turn the wheelchair, having a narrow tire is actually easier to turn because there's not much friction with the ground. There is not much contact with the ground, correct or not? If your tire is very thick, it's very hard for you to turn because when you try to turn, right, the tire will have a lot of friction with the ground, which is not good if you want to turn very quickly. In sports, you need to move very quickly. Okay? So we say it is easier to turn. Yeah? Easier to turn because there is lesser contact with the ground, not so much friction. Okay, not so much friction. Okay, next part is the height of the seat. Yeah, the height of the seat. You can see this wheelchair, right? The seat is like in the middle, like when you sit, okay, your butt is like in the middle of the circle already. If you, I don't know whether, I mean, you probably never noticed this before lah, but a normal wheelchair, right? Okay, a normal wheelchair, your seat, you look carefully, your seat is almost at the top of the wheel already. Do you notice that? Yeah, your seat, your buttock, right, is almost at the top of the wheel already. But if you use a sports wheelchair, let's say a Paralympic wheelchair, okay, you can see the person sitting, right, is like very, very down, very, very inside one. It's like you're very, very inside one. Okay, can you see here? You're very lower, almost in the middle. This one, almost in the middle of the wheel already. Okay, so we want the height of the seat to be a low height of seat. And there's a reason for that one. The reason is so that you are more stable. Okay, lower center of gravity. The lower your weight, the lower you are, the more stable you are actually. The lower the center of gravity, which is where your weight is, the more stable you become. You don't fall to the side so easily. Okay, that's why a tall thing is much more unstable than a short thing because the center of gravity is different. This center of gravity is very high up. So a tall thing is easier to fall over than a short thing. Okay? And then the last one is the angle of camber. Now, if you don't know what is angle of camber, they drew for you in the picture already. Angle of camber is how much the wheelchair is slanted out. Big angle of camber means the wheelchair slant out even more. I mean, the wheels come out even more. Okay, so the angle of camber actually should be big. Again, it's not like a normal wheelchair where the wheels are straight like that. Okay, the normal wheelchair wheels are straight like that. No, this one the wheels have to be slanted out because it also makes it more stable. Okay, you can say more stable, you can say increased stability. Because, right, if you compare a triangle or a pyramid shape and a rectangular shape that is the same height, yeah, same height, this thing will be more stable because the base is actually wider. The wider your base, the more stable you are. Okay? That's why if you open up your feet like that, it's harder to fall down compared if you put your feet together. Okay, you put your feet together, you fall down easily. Okay? So bigger angle of camber. So our choice would be big diameter, narrow tire, low sitting height, big angle of camber. So wheelchair R lah. So remember to write wheelchair R, wheelchair R is most suitable because, okay, so remember to write down this, because it has, you should write, because it has this. Okay? It has big diameter of tire, it has narrow width of tire, low height of seat, so on and so forth. Okay, understand? Yeah. All right. Now let's do one more question, one last question. On page number 10 and 11. The table is on page number 10, but your table is in page number 11 lah. Okay, right. So page 10 and 11. Okay, so again, on the left is your characteristics, or you can write aspect. Okay, and then your reason. Okay, let's see what we're trying to choose here on page number 10. We are trying to choose the best jet engine, the most suitable jet engine. Okay, based on this, based on this. This is the jet engine picture. Okay, so let's choose. Number one is the nozzle diameter. If you don't know what's a nozzle, never mind. Look here. Yeah, nozzle, they accidentally wrote the Malay version, okay, but the nozzle is this. You can see this is the back part of the engine. This is the front part of the engine. This is the back part of the engine. So the back part of the engine is where the hot gas fly out, correct or not? Just now we said hot gas shoot out from the back of the engine. So this nozzle should be big or small. It should actually be small. Small nozzle diameter. Okay? Why should be small, right? If you ever use a hose, a garden hose, or a pipe, and when there's water coming out, if you cover half of the pipe, if you cover half of the hose, the water is going to spray out very fast. Correct or not? Instead of the water just flowing out only, the water gonna spray out. Agree? Yeah. So this, right, is the same for the hot gas. If let's say you make the hole smaller, the hot gas will shoot out much faster. Okay, than compared to if the diameter is bigger. So you can say you can get high velocity of hot gas. Okay, yeah, you have a high velocity of hot gas. Okay, that's for the nozzle. Okay, next is the propeller. The propeller size. Again, look back at the picture. Propeller is this, the kipas, the fan. The fan in the middle, do you know what is it for or not? The fan in the middle is not to blow air to you. It's to blow air into the engine. In other words, right, the fan is to suck air in. Okay, so do we need more air? Yes, which means we need a bigger fan. So bigger propeller. Okay, bigger propeller. Now, do you know why we need to suck in more air or not? Yeah, why do we need to suck in more air? It's for the combustion. It's for the burning. When you burn something, you need three things: the fire, the fuel, and oxygen. So the more air you bring in, okay, you can say to suck in more air, to suck in more air for combustion. The more air you bring in, the more complete your combustion. You will get a much better combustion. More complete. Okay? To suck in more air for combustion. Now, the type of fuel. Okay, you might not know what kind of things these are. So this one probably, again, you have to do more exercise, then only you will know what are these things. Okay, so okay, another way, of course, you can see small diameter nozzle, big propeller. Of course, you know these are gonna hit because this one sure cannot already one. You need all four to hit. So you know you're gonna choose kerosene and big combustion chamber lah. Okay, but just to let you know, paraffin is wax. You know, like candle wax? Candle wax? Paraffin is like that. So takkan you use wax to burn, right? I mean, it can burn, but you're gonna get like a candle flame only lor. If you use paraffin, it's gonna be like candle fire only. That's paraffin. That's small combustion only. Liquid hydrogen is also not very suitable for combustion. Liquid hydrogen is usually used for what? Liquid hydrogen, you can see, yeah. It is actually mostly used for what? Mostly used for, I mean, it's fuel also, but you can see that we don't really use it much. Probably to produce like a bit of electricity, maybe. Yeah, a bit of electricity. But it's very, very not efficient. It's very, very not efficient. And it is very expensive also. Okay? Very not efficient and very expensive. So we won't use liquid hydrogen for our jet engine. Otherwise, your flight tickets is gonna be like millions of ringgit already. Okay? Because it's so expensive. So we will use kerosene. Kerosene is what? You see movies, right? They have this red tong. Or let's say you play game like you play PUBG. Inside got this red tong, right? This tong for gas, that is called kerosene. Or you watch movie when people they kill someone, they want to burn the evidence. They want to burn the body, burn everything. They will pour the oil. That's kerosene. Kerosene is oil. Okay, like the normal gas that we use. So we're gonna use kerosene for fuel. Okay, because it has higher level of combustion. It will really, really burn. Really, really burn. Not like the wax, you only get like a candle flame only. Okay, that one is small combustion only. this one will really, really burn very big. Okay? And the last one is the combustion chamber. So big combustion chamber. So what is combustion chamber? Combustion means burn. Chamber is the room where you burn. So the room where you burn, right? Why should it be big? Because remember, why do you burn? You burn to make the gas. So the bigger the room, the more gas you can produce lah. Correct or not? The bigger the room, the more hot gas you can produce. So that's why you can say, produce more hot gas. Okay? Bigger combustion chamber can produce more hot gas. Okay? So our final choice will be L. So you say jet engine L. Jet engine L is most suitable because it has all this. Okay, right? Any questions for this? Any questions up to here? Okay, so I have a request, okay, that you, okay, by the way, all the answers for the rest of the questions that we didn't do, all of them, they are on the website already. Just go back to the website where you join this seminar. The answers are there with the PDF notes. Okay. So my request is that you go and read all the essay questions. Read the answers for all the essay questions. Yeah. Because again, it's all about common sense. You have to gain that common sense. Okay. Right. So any questions so far? No, okay. So sorry about the voice, because I'm still a bit sick, okay. But if there are no questions, then I will see some of you in our regular classes next week. Okay. All right. Bye bye. Okay. Thank you. Bye bye. Okay. Thank you. Bye bye.